Hello, Ripple folks. This is Ron, or Karma Coverage on the forums, and I wanted to take a minute here to point out an answer when I saw James Fillin's document that he posted on things to come up. We have point number 5 here. The SEC has to answer whether the XRP ledger was fully functional when the XRP distribution started in 2013. But there first needs to be, let's see, a meet and confer, okay, blah, blah, blah. The point is, I've been around the XRP since 2013, and I want to talk about how the pathfinding functionality was fully functional from day 0 with the XRP ledger. It was one of the things that so impressed me with the XRP ledger, and I feel like there's a relatively easy answer here to this number 5 point. So I actually had made a video the other day. I'm going to play a couple seconds of it because I made the point here that when you're burning your fee, you're paying that transaction fee for a transaction on the XRP ledger, you're consuming the routing functionality that the pathfinding does or performs. And so let me play a quick clip, and I'm going to show you some other things. And as it turns out, instead of routing the money through here and paying, let's say a negative 1% fee, it's cheaper to route the liquidity around here. So when you pay that XRP that you burn for the transaction, you're paying for this decision to be made on your behalf. Okay, now I'm going to get to this in a second, but just to give you a visual before I show it to you. Not only does the pathfinding function route through these trust lines as I drew them out between these various wallets, but it will also find the cheapest path through order books. So you get the benefit of both. This is from XRPL org. So what this says, the key point here is that the XRP ledger paths define a way for issued currency payments to flow through intermediary steps, meaning all around through these trust lines or through these order books, from the sender to the receiver. It'll go cross-currency and connect through orders in the XRP ledger's decentralized exchange. The paths also enable complex settlement of offsetting debits. I'm going to leave that alone because whatever. So the two things here, the path is made of steps that connect the sender to the receiver of the payment. Every step is either rippling through an address with the same currency, so that would be these trust line connections here, or exchanging currency at an order book. So as I drew it, that would be, running the value through here. Now, here is the actual code. This is the Pathfinder within RippleD, which is the software that runs the XRP ledger. And so, core pathfinding engine. The pathfinding request is identified by category. So there's different types of payments or different types of transactions. We've got XRP to XRP. There's actually no pathfinding performed there. We've got XRP to non-XRP. That's going to hit your order books. We've got non-XRP to non-XRP. Again, that's going to hit your order books. We've got same currency, non-XRP to same currency, non-XRP. That's going to be your trust lines going through here, connecting the wallets. And we have cross-currency non-XRP to non-XRP. So that could use any of the trust lines and also the order books and a combination thereof. For each category, there's a table of paths that the Pathfinder searches for. Complete paths are collected. Each complete path is then rated and sorted. Paths with no or trivial liquidity are dropped, so that's going to help save the network, not wasting computation. Otherwise, the paths are sorted based on quality, liquidity, and path length. The path slots are filled in quality, which is a ratio of quality in and out. I haven't made a video on trust lines yet, so that's a feature of trust lines, and I guess also order books, with the exception that the last path must have enough liquidity to complete the payment, assuming no liquidity overlap. In addition, if no selected path is capable of providing enough liquidity to complete the payment itself, an extra covering path is returned. So if we come back over here, let's say we want to send $100. If we can only get, say, $60 through the trust lines, we might be able to get the other $40 through the order books. So the amount of work that pathfinding or functionality that pathfinding provides is very significant. The selected paths are then tested to determine if they can complete the payment. If so, at what cost? If they fail and a covering path, so that would be a secondary path, was found, the test is repeated with the recovering path. If this succeeds, the final path and the estimated cost are returned. Now, that's a lot of functionality, and this has been in the XRP ledger from day zero. It's one of the things that just so impressed me when I found the XRP ledger. I'll leave that alone. Now, to compare that to, say, Ethereum or Bitcoin, same thing applies. The gas or ether that you burn is referred to as a fee. It's putting a value on the price. But what you're really paying for, the gas, is used to allocate resources of the Ethereum virtual machine, so that a decentralized application, such as a smart contract, can self-execute in a secured, decentralized fashion. So effectively, what you're paying for when you're burning ETH, as compared to burning an XRP for a transaction, is you're paying for the electricity and the hardware of the miners. And this is one of the reasons I'm so excited about Flare. I'm embarrassed I didn't see this myself, but the way they articulated this was significant, the economics of it. So, right, where is it? Around here. All right, so they're saying two reasons why Flare exists, two key issues they're trying to solve. I'll leave the first alone. Here, the immediate issue inherent with proof of stake, this also applies to proof of work, is that the consensus design doesn't yet safely allow for alternative uses of the native token. This creates a economic problem. If the token holder can obtain a higher yield with no possibility of slashing by providing collateral to create a stable coin than they can for staking, so now you have the users having forced into a decision: do I stake or do I put it into a stable coin as collateral? Then the economic rationalists will likely do so. This diverts the tokens away from staking and cannibalizes the safety of the network. Back over here, the gas is used to allocate resources to the Ethereum virtual machine so that the smart contracts can self-execute. So a highly insightful paper on the topic was here. We suspect that perhaps the key reason why, despite having comparatively higher transaction costs and lower transaction throughput, Ethereum is still leading in DeFi. So here's actually the paper. It looks like it's a Cornell paper, competitive equilibria between staking and on-chain lending. So they're basically just positioning the economic decision or conundrum that the owner of the ETH is stuck in. I'm just going to come back over here because this really struck me. By providing collateral to create stable coins, they are away from staking. So somebody takes their coins out of staking and puts them into providing collateral. The economic rationalist will do so. This diverts tokens away from staking and cannibalizes the safety of the entire network. So I started this little chat because there was some talk about AMMs and pathfinding, and in my head I was looking at pathfinding as somewhat like an automated market maker because it's sorting all these paths to find liquidity. It's maybe not exactly the same, but I wanted to point out JN_R. He's been around for a while. I know he's a knowledgeable guy, and he said that with an AMM, the market making is automated. No orders have to be placed. So they abstract away the order book. What he did say is also Ethereum, on Ethereum, AMMs can be placed in a row. For this, you need a pathfinding algorithm. Again, the routing function is critical, which Uniswap has built in. So that, I think, also drives home the point that when you're paying that ETH fee, you're really only paying for the electricity and the hardware, versus when you're paying that XRP fee. Now, and also with the Ethereum fee, the ETH you burn goes to the miner. So it comes out of a user's wallet, an end user's wallet, into a miner's wallet. With XRP, when you pay that fee, it's burned and gone. Nobody gets it. There's no profit that Ripple or anybody else makes. No validator gets the XRP that's burned. So you really are paying for this pathfinding functionality. So I hope that helps somebody understand and helps address this question here that the SEC has to answer. I feel like I've given them the answer. The SEC has to answer whether the XRP ledger was fully functional when the XRP distribution started in 2013. I would say it was. The XRP pays for this pathfinding functionality, which is critical and, quite frankly, financial engineering genius. Hope that helps everybody. Have a good day.